So we have completed the exploratory data analysis. After exploratory data analysis, inferential statistics, hypothesis testing. So after EDA, if you have missing values, we'll go to data pre-processing. If there are no missing values, we'll go into hypothesis. So hypothesis testing is a statistical inference method to validate a particular hypothesis. Hypothesis is a probabilistic statement, population parameters. Hypothesis is a probabilistic statement about population. So in hypothesis testing, there are fundamental assumptions. The numeric variable must be closer to normal distribution with minimum missing values. The means or the averages, groups or levels in categorical. So mean difference is also a fundamental assumption. The procedure first, we will run the group by to know the mean or average difference and how many levels in categorical and alternate hypothesis. Second is identify the test. Inference based on group by function must be run to know the mean difference or average difference and to know how many levels are there in categorical variable. Then we'll identify the hypothesis test. Then we'll frame the null and alternate hypothesis. We will conduct the test. No, before conducting test, we have to split data. So we have to split the data into as many levels, classes or groups, then conduct the test, then inference based on p-value. P-value less than 0.05, we will reject the null hypothesis. P-value greater than 0.05, we fail to null hypothesis, which is nothing but accept, but we should not use the word. So we will go with simply p-value based interpretation. As part of the test output, you will get p-value. We will simply go with the p-value based interpretation. P-value less than 0.05, reject the null hypothesis. P-value greater than 0.05, fail to reject the null hypothesis. 0.05 means 5% or probable error rate and 95% confidence level. 0.05 means 5% alpha or probable error rate or the probability that the decision we are making based on the p-value is wrong and 95% confidence level. We have a variable, let us say test null, the average CNT of bicycles on holiday 0 or 1, which is nothing but 0 represents no, 1 represents yes. Test null, the average CNT of bicycles rented on holiday 0 or 1. Holiday is in the nature of 0 and 1. 0 represents no, 1 represents yes. This is the hypothesis we are going to test. First thing is, we have to check the numeric variable closeness to normal distribution. We have checked yesterday in CNT. It is somewhat closer to normal distribution. Somewhat closer to normal distribution, right? With no outliers, right? And there are no missing values also. So the first assumption is, what is the first assumption? That the numeric variable must be close to normal distribution. In this case, the numeric variable is what? CNT. Count of CNT means count. Count of bicycles rented is numerical, which is closer to normal distribution. Now, first thing is you have to run the group by function. Bike data dot CNT dot group by bike data dot holiday dot mean. Once I run the group by function, I found out there are two levels or groups or classes, categorical variable. There are two levels or groups in the classes in the categorical variable, and the means, the levels or groups or classes, the means or averages, the mean is different, right? There are two levels, which is no, one, which is yes. 0 days demand is 4,527 on an average. 1 is 3,735. So the second fundamental assumption is the means must be different. Now the means are different here. The means are different here. The means are different. When one variable is numeric and other variable categorical exactly levels or groups or classes, the hypothesis test two sample independent when one variable is numerical, the other variable is categorical with exactly two levels, not less, not more. Exactly two levels or groups or classes, then we run a test called two sample independent t-test. The hypothesis test to use when there is a numeric variable and there is a categorical variable with exactly two levels. Two sample independent t-test is the test we will be using. So, based on the group by function, we have found out there are two levels in our data and the mean or the average of the two levels is different. And the test we are going to use is two sample independent t-test. The null hypothesis for this statement, for this test is there is no significant CNT of bikes on 0 or 1. Or in layman terms, both means equally. Statistically, there is no significant difference in average CNT of bikes on holiday 0 or 1. In simple terms, we can say both means can be treated equally statistically, not numerically, or difference in means is statistically insignificant. The alternate hypothesis is exactly the same statement. Just remove the word no before significant. The difference between null and alternate is the word before significant you have to remove. There is significant difference, cannot be treated equally. Difference in means is statistically. The null hypothesis is no significant difference in means. Alternate is there is significant difference in. So the difference between null and alternate is it is the word no before the word significant. No significant and significant. No significant difference, significant difference. We have to split data. Holiday yes is equal to bike data square bracket bike data dot holiday double equals to 1. Holiday no is equal to bike data square bracket bike data dot holiday double equals to 0. So we are splitting the data into two data frames. Holiday no. S is where holiday double equals to 1. No is where holiday double equals to 0. SciPy dot stats t-test underscore end. T-test underscore end holiday s dot comma holiday no dot CNT comma equal underscore where is equal to false. P value is greater than 0.05. We fail to reject null. That means the mean difference is statistically, we are accepting the null hypothesis. That means the difference means is statistically insignificant. Equal variance. So there are two tests. T-test assuming equal variances, T-test using unequal variances. Equal variances is a hypothetical test. It doesn't happen in real time. It happens only in economics data, interest rates and all. But other data, we always have variance unequal. You can test also. Like how we did group by with mean, we can also do group by with var. So look at the variance. It is different, right? Are the variance equal? That is why I said equal underscore var is equal to false. That means variance is not equal. Equal underscore var means equality of variance. Equal underscore var means equality of variance. So the mean difference is statistically insignificant. Basically, what I can say here is the demand for bikes is not affected by holiday. The demand for bikes is not affected by when the hypothesis is rejected. No, we always talk in null hypothesis. When the null hypothesis is rejected, relationship is there between variables. When the null hypothesis is failed to reject, there is no relationship between, or one variable affects the other is not there. All right. So the procedure is important. First, group by to know the mean difference and also to know how many levels are there. Then we'll identify the test based on the number of levels. Then we'll frame the null and alternate hypothesis. Then we'll conduct the test and we'll interpret it based on the p-value. Simple p-value is what we are going to use. Now, let us do one more test. Test now the average on holiday average temp on holiday 01 equal. First do the group by to make sure that the means are different. Pike data dot temp dot group by pike data dot mean. 0.49, 0.46. The means are different. Similarly, find the variance also. Even the variance is also different. Mean is different. Variance is also. There is no in average of holiday 0, 1. I will copy the same statement. Control C, paste it down. Control V, change the null to alternate and remove the word no before significant. The difference between two statements is the word no. This is the only difference. Test function is already imported. Data is already split. So you can run the test directly. Test function is already imported and data is also already split. You can run the test directly. Holidays.temp, holiday no.temp, equal var is false. Less than 0.05. It's not 0.5, it is 0.05. Is it less than 0.05? How can it is less than 0.05? Is greater than 0.05. Fail to reject 0.05 or 95% confidence level. 0.5 means what? 50%. 5%. 0.05 is 5%. It has to be less than 0.05. So all of you open day.xlx, yesterday's Excel sheet. The Excel sheet we were working yesterday. Open that Excel sheet. Open the Excel sheet. We were working yesterday. Day.xlx. Now go to the column F, holiday. Go to the column F header, holiday. Home tab, sort and filter, apply filter. In the home tab, right side, you can see sort and filter. Click on filter. You can see the filters are added to the headers. Click on the holiday header, home tab, sort and filter, filter. Now go to the filter next to holiday. You can see the drill down. Unselect all, filter next to holiday, unselect all. Then select only 0. Now go to the right column, CNT. CNT column is there, na? Control Shift down arrow. Go to a new sheet, paste it. CNT _ 0. So go to the filter under holiday, unselect all, select only 0. And then go to the CNT column. Control Shift down arrow. Select the complete CNT column. Go to a new sheet, paste it like this. CNT, paste it and rename the column as CNT _ holiday 0. So after applying the filter, select the CNT column, Control Shift down arrow and paste it in the new sheet. First select only holiday 0 only. See, only holiday 0 you select. First unselect all, then click on 0 only. Then you go to the CNT column. You can go to the CNT column directly, Control Shift down arrow. Okay. Go back to the holiday, unselect 0, select only 1. Now go to the CNT column again, Control Shift down arrow, Control C, paste it here, CNT _ holiday 1. So we are splitting based on holiday 0 and 1. First holiday 0, then the CNT column, then untick 0, tick mark 1, then the CNT column. So you select CNT column. Not there. Click on the header. Control Shift down arrow. Name it _ holiday. CNT _ holiday. Got this? Now for holiday 0 and holiday 1, calculate the count, calculate the mean or average. So is equal to count, Control Shift down arrows, close bracket, enter. You can simply drag to the right. Is equal to average, close bracket, enter. Is equal to var, Control Shift down arrow, close bracket, enter. Mean and variance in Python also, right? Is equal to count, is equal to average, is equal to var. Is equal to count, is equal to average, is equal to var. And then you can drag to the right side. So T statistic formula is mean 1 minus mean 2 divided by square root of variance 1 and variance 2. See, the formula is this. Now, if you look at Python, we got something called this, right? Statistic. This statistic, you see in Python, minus 0.700070. Sorry, not this one. The T statistic is minus 1.70 something, you're getting it, right? This statistic is calculated using the formula this. mean 1 minus mean 2 divided by variance square root of variance 1 by n1. See, this is the formula using which the t statistic is calculated. Mean 1 minus mean 2 divided by square root of variance 1 by n1 plus variance 2 by n2. This is the formula the t statistic is calculated. Based on the t statistic, we will calculate so this is the formula for t statistics. Mean 1 minus mean 2 divided by square root of variance 1 by n1 plus variance 2 by n2. Now, you can see here I have given in Excel sheet the formula with all the things. So, for calculating the t statistic, what we need? We need the mean, we need the variance, we need the count. Now, if you want, you can calculate numerator and denominator separately, or you can do it in one go. So, is equal to open bracket mean 1 minus mean 2 divided by of open two brackets variance 1 by n1 close bracket variance 2 open bracket variance 2 divided by n2 close two bracket. See 1.704. We got the same value. See 1.7046852. So t statistic formula is this. You can look at the formula. Is equal to open bracket mean 1 minus mean 2 close bracket divided by SQRT square root of open two brackets variance 1 divided by n1 close bracket plus open bracket variance 2 divided by n2 close two brackets and press enter. S square represents variance, S represents standard deviation. S square in statistics represents variance. S represents standard deviation. S square is variance. S is standard deviation. This is the exact process repeated by Python or R or SAS or SPSS, any software will repeat the same process. Split the data, calculate the average, variance and count and use the formula mean 1 minus mean 2 divided by square root of variance 1 by n1 plus variance 2 by n2. So across statistics, S square represents variance. S represents standard deviation. Standard deviation also, sigma square also reference variance. Sigma refers to standard deviation. Sigma square is variance. Sigma is, okay, 1.7048, right? Now we have to calculate degrees of freedom. Degrees of freedom is n1 plus n2 minus 2. n1 plus n2 minus 2. That means is equal to 710 plus 21 minus 2. Then we need to calculate the p-value. Is equal to t dist. Is equal to t dist. X is 1.7. Degrees of freedom is 7.729, comma, rejection on both sides. Oh, different value. Huh? Well, we got 0.08. Why we are getting a different p-value? We got 0.10, right? Okay. Why we are getting a different p-value here? We got a different p-value here. Why we are getting different p-value? In Python, we got 0.10, right? We got the t statistic correctly only, but p-value is not coming correctly. We got the p-value, some problem with the p-value. Okay, let us see. What is the issue? Data analysis, p-test assuming unequal variances. Yeah, we got 0.103 here correctly. So degrees of freedom, it is taking as 21. Huh? Yeah. So degrees of freedom is taking as, then we are getting the same value. For degrees of freedom, this is the formula. It's n1 minus 1, n2 minus 1, which is nothing but n1 plus n2 minus 1. But they are using this formula maybe. Here it is n1 plus n2 minus 2. Oh, minus 2. We have used minus 2 only, right? But still, then they might have used the statistical formula. So this is the degrees of freedom formula, which is used by softwares to calculate variance by n1 plus variance by n2, variance by n1 minus. Okay. So I'll show you how to calculate. All of you open data analysis toolpack, data tab, data analysis toolpack, which we have imported yesterday, data analysis toolpack. If you scroll to the last, you will see t-test, 2 sample, assuming unequal variances. Variable 1 range. Select the first variable column, variable 1 range, including the header. select the first column, variable to range, select the second column, tick mark labels, and output range, select some empty cells. Select some empty cells in output range and click OK. Variable 1 range, first column of CNT holiday 0, variable 2 range, CNT holiday 1, tick mark labels, output range, select some empty cells. Select some empty cells, just click OK. Using this formula, it has calculated. Got it? 21, no? Everything is same? No. That means it's wrong. You missed one observation. 710 and 21. 731 has to be there. Observation. 20 you got, huh? No. P-value is correct or not? You got two-tailed P-value 0.10. Including headers you have to take. Otherwise, it will take the first one as header. Including headers you have to take. You might have missed that one. Reselect the data variable 1 range. You have to take the headers also. And then tick mark labels is equal to TDIST. Then give the T statistic 1.70, comma 21, comma 2. So there is a statistical formula to calculate degrees of freedom. The formula is this. You can see here, right? The formula is this. Variance 1 by N1. So is equal to open bracket, open 2 bracket, variance 1 by N1 close bracket plus is equal to the power of 2 divided by open 2 brackets, variance 1 divided by to the power of 2 divided by this minus 1 close bracket plus open 2 brackets, variance 2 divided by N2 to the power of 2 divided by open bracket. You'll get degrees freedom as 20, close to 20 something you'll get. I might made a mistake in the bracket somewhere. So I'm getting it to 19 point something, but this is the formula. 1 second, let me check. Show me what is the problem?
Variance value.
Which variance value got wrong? Is equal to var, VAR.
Yes.
VAR only. Plain one. You have the plain one. No? Use the plain one. So you corrected it. Degrees of freedom 21 you got. So this is the formula that it uses to calculate variance. Statistical formula. Manual formula is N1 plus N2 minus 2. In normal manual statistics, N1 plus N2 minus 2. Anything is okay. Okay. So you will get the same answer. See here, two-tailed test for 0.1030, which you got in Python, exactly same. Got it? All of you got the output? So you have to check for two-tail. So two-tail means rejection on both the ends. Because we are using is equal to, right? Not t-dist, dot above. Only t-dist. See, in hypothesis test, we have two types of test, one-tail test or two-tail test. One-tail test or two-tail test. If you are doing left-tail test, mean greater than equal to value. If you are doing right-tail test, mean less than equal to value. But what we are doing is equal to. We are testing test null, the average CNT of bikes on holiday 01 equal. I am using the word equal. If you use the word equal in hypothesis statement, it becomes a two-tailed test. Two-tailed test means rejection on both the sides of the, that means 0.05 by 2, 0.05 by 2. In business and in real time, we use two-tailed test. Two-tailed test means we use the word equal in our hypothesis. If you don't use the word equal, if you use the word greater than or less than, either greater than or less than, it becomes a one-tail test. If you are looking at left-tail test, it is greater than. If you are looking at right-tail test, but in business we use, which means equal to. Mean 1 equals to mean 2. Mean 1 not equal to mean 2. Mean 1 equals to mean 2. Mean 1 not equals to mean 2. That is what we are testing. So our test is two-tailed test. So when you look at the output, you also look for two-tailed value. P value two-tailed, which is 0.10. By default, Python also does two-tailed test only. In Python also, we got the P value 0.1029, which is rounded up to 0.1030. It is a two-tailed test. Interviews, they will ask you, what is the difference between one-tailed test and two-tailed test? Two-tailed test, equality. One-tailed test, either greater than or less than. Left side is greater than, right side is less than. Or simply say, One-tailed test uses either greater than or less than in its hypothesis, whereas two-tailed test will use equal. Mean 1 equals to mean 2. Mean 1 not equal to mean 2. That it becomes a two-tailed test. Or less than. If you're using these symbols in your hypothesis test, it becomes a one-tailed test. But in business, we always do two-tailed test. That's why in hypothesis statement, I am asking specifically the word equal. Test null. The average CNT of bikes on holiday 01 equal. Once I use the word equal, it becomes a two-tailed. Okay. If I use the word greater than mean or less than mean, it becomes a one-tailed test. In two-tailed test, rejection on both the sides. So you will divide the alpha by 2, 0.05 by 2. So on the left side, 0.025. On the right side, 0.025. Rejection on both the sides. Whereas in case of the other test, it depends on the symbol. Greater than on the right side, sorry, less than on the right side, greater than on the left side. Yeah.
But finding mean only we came to know that.
But what it test says, the mean is not the significant, it's not significant. You say mean is different, right? That too we have a big difference. 4,500 and 3,000 something. But what the test is saying, that difference is not at all significant. You can ignore the variable. What it's saying is that difference is there now. 4,000, almost 800 bikes different is there, right? It says the difference is not significant. You can ignore the variable. That means holiday is not affecting the demand. You can simply say holiday is not affecting the demand. So this sort of analysis you can make. What are, see, first, there is a big difference between means, right? 800 bikes is the difference in demand, right? You can see, right? 4,527, 3,735. Huge difference is there. But what hypothesis testing is telling us? That difference is not statistically significant, or it is not affecting your demand for, it is saying you can ignore the variable or ignore the difference. You can treat both of them as, what the point? Mean says there is a big difference in demand, but the test is saying that difference is not significant. There is no much difference in the demand, whether it is holiday or not. Boys scored 78%, girls scored 77%. Only 1% is different. Is it a big difference? It depends on the population. How many girls you have, how many boys? If there are very few girls and then they score 70%, 77%, then the difference becomes a significant. If the both are equal, then the difference becomes, so you have to look at the population also. The population is also very important, not the denominator, N1. N1 and N2 are also going to play a big difference, right? In the formula, N1, N2 is there, na? See, S1 by N1 plus S2 by N2. So all this parameter is saying is that there is not much of a difference in demand for bikes, whether it is a holiday or not. Numerically, there is a difference. Numerically, there is a difference. But statistically, that difference is not. Statistically, that difference is not. See, why I am pushing it is, you will get compulsorily hypothesis questions in your interviews. At least 2 of them. So you should answer them confidently. Common questions are, what is p-value? What is null hypothesis? What is alternate hypothesis? When do you use two-sample t-test? When do you use ANOVA? Like this, these are the common questions you will get in hypothesis testing. Compulsorily, you will get at least 2 or 3 questions in hypothesis testing in your interviews, as well as in your MCQ test. In MCQ test also, there are 2 or 3 questions will come. Typical questions are, when to use which test? What is p-value? What is its significance? When will you reject or when you fail to reject null? What is the null statement? What is an alternate statement? Like this, they will ask you questions, right? It's 4 o'clock, you can take your break. After coming break, we'll go through the concept one more time. I know this is from now onwards, little bit complexity will be there. As we go on in the curriculum, it will be little bit complex. But we'll make it easy with all the notes and all. Okay. You can look at the Excel sheet where I am giving you the complete notes, formulas, everything. See, not that you need to remember the formulas, but you should understand the concept. That is why we are doing the manual calculation. Otherwise, in Excel also we have an automated, right? T-test assuming unequal variances. Select them and it will give you the output. But to have an understanding of the concept, it's better to have a calculation understanding. All right, you can take your break. One variable is numeric and other variable is categorical with more than 2 levels. See, in t-test, exactly 2 levels, not less, not more. If there are more than 2, then we have to use something called ANOVA single factor, also called as, if your categorical variable has more than 2 levels, then we have to use ANOVA single factor or one-way ANOVA. The process remains the same. First, you have to do group by. Next, you have to split the data into as many levels, then null and alternate hypothesis, then conduct the test, and interpretation is based on p-value. Same p-value, less than 0.05. In fact, in across machine learning, wherever you see p-value, it must be less than 0.05. We'll come across p-values in regression. We'll come across p-values in what you call neural networks. We come across p-values in some statistical computing methods like which we use in R. Wherever you see p-value, it must be less than 0.05. So whenever there is a p-value, it must be less than 0.05. Whenever there is a p-value, there is a null and alternate hypothesis. Now, the process is exactly same. Test null, the average CNT of bicycles different. When I use the word equal, it becomes a two-tailed test. When I use the word equal, it becomes a two-tailed test. Bike data dot CNT dot group by bike data dot season dot mean. And remember, this is one of the interview questions and written tests. Hypothesis testing is comparison of what? Means or averages. Not median, not standard deviation, not skewness. It is only comparison of means or averages. In Excel, average. In other places, we call it as mean. Hypothesis testing is comparison of means, not median, not standard deviation, not variance. Okay, so remember this thing. It is only comparison of means of groups or classes. So as you can see here, season has more than 2 levels. Season has more than 2 levels. Season has more than 2. And the means are different. Means are different, right? More than 2 levels and the means are different. So season 1 is, season 2 is summer, 3 is fall, 4 is winter. In the text file which I sent you yesterday, here you can see, right? 1 is spring, 2 is summer, 3 is fall, 4 is winter. 1, 2, 3, 4 means spring is equal to bike data, square bracket, bike data dot season double equals to 1. You can copy the top statement down, double equals to, paste the statement, change it to 3. Copy paste the statement with the names spring, summer, fall, and winter. Control C, Control V the statement, okay? And give the name. Make sure you change the numbers correctly. Significant CNT of, and then copy paste the statement down, change the null to alternate, remove the word no before significant. There is significant difference. All of you go to Google and type scipy.stats. Scipy.stats. All of you type in Google scipy.stats. Like I told you, this is part of NumPy. Introductory session I told you, right? In NumPy, scipy.stats is a sublibrary of NumPy. Scipy.stats. SCIPY.stats. You'll get the statistical functions in SciPy. Scipy.stats. Control F will open a search window and type ANOVA. Control F will open a search window and in the search window type ANOVA. Scipy.stats, the first link, click on it. Control F, type ANOVA. So it is going to that function. Perform one-way ANOVA. And the function is F underscore one way. Click on this function, you will get the function details. The null hypothesis is given here also. If at all you forget or you want to record it, it is there in the test also, right? Click on that F underscore one way. It says the one-way ANOVA test, null that 2 or more groups have the same population, right? Now, if you go back, t-test and type t-test, calculate the t-test for means of 2 independent samples of scores. T-test underscore ind. See, the test for the 2 independent samples have identical. See, everything is there in the documentation. You just need to refer to the function and you will get the null statement also. So scipy.stats is for the statistical modeling. Control F, type the function name, you will get it, the function. So we are looking at perform one-way ANOVA, which is F underscore one way. Got it? How to search for functions? Just go to Google, type the library name, you'll get the search window or control F and you can search for the function. Because there are a lot of things nobody can remember, even I can't remember, right? So we need to know how to browse through the documentation also. We need to know where to find the function. Statistical functions, scipy.stats. Pandas functions, pandas library, right? Read CSV, plot, all these things are pandas. You will find them in pandas library. So you should be knowing where to find what. From scipy.stats, F underscore one way. F underscore one way. F underscore one way, spring dot CNT, summer dot CNT, comma, call dot CNT, comma. So p-value is less or greater. It's very, very less than, because E minus, that means 0 point after 66 zeros, the value will start. E minus, this is far less than 0 point. You have to look for E plus means millions or billions. 1 plus. It is minus means after 0 dot and 66 zeros, you will get the value. We will reject the null hypothesis, which means difference in means statistically significant. Got this? Same procedure. Only thing is more than 2 levels. More than 2 levels. You have to split the data into as many levels as you have. First, group by, split the data. Then null and alternate. Then can import the test function, conduct the test. Simply go with p-value. Only p-value less than 0.05. 0.05 means 95% confidence level. 5% error. 5% that my decision is wrong. Or 5% the test is wrong. 95% the test is correct. Alternate hypothesis or alternate p-values. No. In hypothesis testing, we always talk in terms of null. Only null hypothesis is the focus area. The other is interpreted. We don't touch the alternate. If you reject the null, you are automatically accepting the. If you fail to reject null, you are automatically rejecting the alternate. You always talk in the context of null. Null is the primary criteria. Across statistics, machine learning, everywhere. Our area of focus is rejecting the null or fail to reject the null. We will only look in terms of rejection of null or fail to rejection of null. The other thing is automatically assumed. Now, p-value, we are using 0.05. In pharmaceutical studies, pharmaceutical clinical studies and drug trials, the p-value is 0.001, 99.99 confidence level. Pharmaceutical studies, clinical studies, drug trials, there the p-value is 0.001, 99.99%. In fact, in biostatistics and pharmacy, the p-value is 0.001. In normal business and economic studies, we go with 0.05, except for pharmaceutical and drug trials and medical studies. There also sampling is different. The sampling, we are taking just the data and we are splitting and doing it. There we can't do like that. There we should have a control group, we should have a treatment group. Because there are rules given by US FDA. Federal Drug Administration has put strict rules for sampling also. Here we don't have such rules. In business, we just take a sample, which is enough for our study and we do it. But in pharmaceutical clinical studies, you can't do like that. There are strict rules which are given by government, the regulatory agencies. That rules have to be followed. So that is a different study. There we use 0.001 p-value. But rest of the times we use 0.05 as our p-value. Test null, the average wind speed, different seasons. Just do group by, frame the null and alternate and do the test. Because the data is already split. First do the group by, find the mean difference. Wind speed, the numerical variable here is wind speed. Is the mean different? Mean is different. Then go ahead and conduct the study. Frame the null and alternate and conduct the study. Because data is already split. So 0.21, 0.20, 0.17, 0.17 is the wind speed. You can copy from top. Instead of CNT, we will take wind speed. Conduct the test and tell me what is your p-value. Less than. So what is the interpretation? That means there is a big difference in means, significant difference in means. Why these guys are hitting like this? అవును చెప్పండి. యూజ్ ఏంటమ్మా, యూజ్ ఏంటి? లేదమ్మా అవసరం లేదు, ప్రస్తుతానికి ఏం చేంజ్ అవసరం లేదు. Let it go with the same thing. F_1way spring dot wind speed dot wind speed dot wind speed. Reject null. In business, when you are making a statement, you should validate it. In business and data science, if you are making a statement, you should validate it with data. You can't make a statement like that. Once you join companies and all, particularly when you join data science, see, programming side profiles, other things are different. Now, when you are working on sales data, you are looking at retail sales. You got a retail sales data set. There you have two types of customers, male customers and female customers, right? Let us say you have 1,50,000 male customers, 90,000 female customers. Now you average the sales of male customers and you average the sales of female customers. You found out on an average, male customers were buying 38,000 rupees worth of products. Female customers are buying 42,000 rupees worth of customers. The manager has passed a statement that female customers are buying more than male customers. So female customers are our important customers. But the other manager disputes it, says it's wrong. Simply females are buying 4,000 rupees difference is there. You cannot say that female customers are better than male customers. When you have such point of conflict, hypothesis testing comes into picture. Hypothesis testing will tell you whether that 4,000 rupees difference between the average purchase of male customers and average purchase of female customers is significant or not. If the test says the 4,000 rupees is significant, then you can write in statement saying that female customers are more important than male customers. If the test says fail to reject null, that means 4,000 rupees is not a big difference, then you cannot say female customers are more important than male customers. You have to treat both the customers as equal. This is validation. Statistical inferential statistics is all about validating the statement. That is what I have told you in the top. Why we do it to do hypothesis testing? To validate a particular, what does hypothesis mean? Hypothesis is the word in Latin. In English, it means a statement. Hypothesis in English means a statement. In Latin, hypothesis means, statement in Latin means hypothesis. But in plain English, hypothesis means a statement. We are going to make a statement and we need to validate it. How do we validate statement? Using hypothesis testing and available data. This is constantly happens. Rural customers are more important than urban customers. Should I focus more on giving discounts to which customer? Which customer should get discounts? Female customers should get discounts. Male customers should get discounts. Customers discounts are different. Male customers discounts are, in female customers you tend to give accessories as additional things. In male customers you look at money, cashback offer or something like that. For female customers we give further purchase coupons. See, there is lot of research done on behavioral patterns and all. The offers which you give to female customers is different. Offers which you give to male customers is different. So you have to do all this thinking. Particularly in e-commerce, it's a very, very complex questions. We work on a lot of hypotheses. Even the web page design, we call it as A/B testing. How should the web page look like? Designers will make a lot of designs, right? Which one is the best design? Which one people want to look at? We call it as A/B testing. That is also hypothesis testing. We give to sample groups different web pages, then we'll take the feedback and then we will do a hypothesis test and then we will decide. So whenever you are passing a statement or a hypothesis in business environment, you have to validate it with a statistical test. Just in case of male versus female customers, or in case of urban rural customers, or in case of high income customers and low income customers. So these constant studies we will do. Facebook ads, campaigns we do now. Lot of data will be generated. Facebook campaigns will generate a lot of data. You have to analyze the data and give analysis to the client. Dell constantly, you see ads, Dell ads on your Facebook, right? If two people sit together, you will not get the same laptop. The ad will not talk about same laptop. It might talk about one laptop model on your Facebook page. On your friend's Facebook page, it will talk about another model. Now, how it will decide? Based on your Facebook profile. If you are a gamer, it will look at gaming laptops. If you are using it for normal basic things, it will put a basic laptop. If you are using for data science and research, it will give you high end. So all these things are not only done by machines, the humans control it. And we control it using lot of these tests we do. A/B testing, hypothesis testing, regression analysis, correlation analysis. All these things are done in the back end by analysts and systems. Data scientists will do this, and finally they will give you the. I don't know how many of you have HDFC bank accounts. HDFC bank accounts, you know, right? HDFC has this concept called Insta loans. No paperwork, nothing. Insta loans. They call them Insta loans. In your net banking, you'll get an offer. You will get an Insta loan of 1 lakh rupees. All you have to say is yes. Within 2 seconds, money will come into your account. No documentation, no loan agreement. Loan agreement also comes later. In normal loan, what will happen? Verification, documentation, agreement signing, all these things also, there is no guarantee you'll get a loan or not. But look at HDFC Bank and ICICI Bank, Insta loans, nothing. You just log in your net banking, click yes. 2 seconds, your money will come into your account. And you will get your loan agreement to your email later. Now, how does system design? Based on your profession, based on your salary, based on all this data is available with the bank, right? It uses to find we call it as segmentations. So these cluster of customers will get this offer. This cluster of customers will get this offer. This all is done by algorithms only in the back. So all those algorithms, some basic simple grouping algorithms to advanced algorithms like neural networks will decide a lot of things. But still human intervention is necessary. Human intervention will always be there. So you understood why we need to do hypothesis. We know the numbers are different. But what hypothesis test will tell you is whether the difference is important or should I give a customer 15% discount? Should I give a customer 10% discount? That is also decision you have to make, right? Not all customers will get the same discount, right? In most of the product categories, particularly laptops, mobile phones, electronics, in Amazon particularly, each customer will get a discount based on his profile and previous purchases. So it all depends on your profile. So a lot of the information data will be there, and then using that data, should I give this customer more or less will be decided by the algorithm. So accordingly, you will get the offers. So this is the purpose of hypothesis statement. Validating a statement or proving that you are right. That is the purpose of hypothesis. In PPTs, you can't just write something. In industry, when I write a statement on a PPT, I have to prove it, right? When I'm presenting to my clients, when I write something, I have to prove it. For that, I have to give evidence in the form of data. Sometimes we have to give statistical evidence. In data science, you have to give statistical evidence. You have to give statistical evidence because that is our job. We have to use statistical models to analyze the data and present it to the client. Analyze using statistical models and present it in the client using statistical analysis. So there we will say. So my analysis found out with a two sample t-test, I found out that male customers are significantly buying more than female customers. Like that, you have to put a statement. So for that purpose, we have to do this hypothesis testing. Validation of a statement or a validation of a hypothesis. The purpose is this. There are many tests. T-test, ANOVA is there, chi-square test is there. Non-parametric tests are there. If your numerical variable is not at all normally distributed. Sometimes we get a non-numeric variable, which is the other day we seen a price in Airbnb, which is completely towards left. There we can't do a t-test. We have to do a non-parametric test. Wilkinson test we have to do. Rank correlation test we have to do. So there are different tests which are used in industry to validate the hypothesis. But that is the critical statement you are making, which will have a business impact. Whatever you are making, that will have a business impact. So it is your responsibility to prove it with data. You have to prove it with data. Without proving with data, nobody will accept your statement in business world. It has to be proven with data. And data is very dangerous. I am telling you. Why Adani is not able to file a case. In that report, Adani is not only allegations. Allegations are made on government of India. There are direct allegations made on Prime Minister Modi. There are direct allegations made on Amit Shah. But what are they doing? They are not doing anything. Because the people who are making the allegations, they have given a 130-page report with all the proofs, and now it is such thing that if Adani goes to court, he will be directly convicted. Hindenburg report. Because a company, a research company cannot simply say Adani is creating, what they said, the report finds statement is Adani, the richest billionaire in the world, is committing a biggest corporate fraud in the history of corporate world. They said a statement, it is the biggest fraud. When they are making that statement, he can sue them in America for making false statement. He can sue it in India also, right? But why he is keeping quiet? Because they supported their statement with very, very detailed data analysis. Very, very detailed data analysis they have done. And that report is such detail that not Adani can do anything, nor Government of India is able to do anything. Nothing. There are allegations made on Government of India. There are allegations made on Prime Minister, both as Chief Minister of Gujarat as Prime Minister of India. There are allegations made on Amit Shah, both as Home Minister of Gujarat as well as Home Minister of India. None of them is talking. None of them is not even disputing it, not even going to court. If it is a false statement, he will go to court, right? Because instead he withdrew the share thing, he withdrew the bonds, he is withdrawing everything from, because they came up with data support. A detailed report they came up, 130 pages with evidence, with complete data they have come up. And now what can Adani do? Nothing. We all know Adani, I never bought Adani shares. Mutual funds never buy Adani shares. We know. Nobody can become a billionaire in 3 years. For how much time it took Bill Gates to become a billionaire? It took him 15 years. Zuckerberg took 10 years. Even Dhirubhai Ambani took 30 years to become a billionaire. And here you have somebody who becomes billionaire in 3 years. Is it possible? That is why people got doubt. How come a person who is nowhere came in top 10 billionaires in the world? That is where they started looking at him. Same thing happened in Mexico 3 years back. A telecom guy, telecom magnate, his name is some Carlos something. He was also similar to Adani. He was the Binami of the Mexican president. Briberies, criminal mafia, all these things. He was also the same thing. So data is very important. You can't make any statement without data. And Hindenburg, guys, a 5-member research team. You know how many people work in that company? 5 people. 5 people work a company, took over a company where 40,000 employees are there. Adani Group has 40,000 employees in different companies. A 5-man team taking on $1 billion enterprise. Their revenues are very small. Hardly $1 billion revenue they have, the Hindenburg Research. But they hit a company, they bought the completely, crushed the company out of the nothing. Adani is now left with nothing. 80% of his wealth is gone. Only 20% is left. 80% actual loss. Because he has his own stake now, he is putting his own. So he is ready to sell shares at 1,000 rupees. But who will buy? He is showing his share value. Yesterday, Ashwath Damodaran is a New York University professor who created this concept of valuation of companies. The actual share price of Adani is 940 rupees. And he said it will be below that, not more than that. Now people are trading it at 3,000 rupees, 4,000 rupees. Now it is 940. Ashwath Damodaran is father of valuation. He is a father. He invented the concept of valuation. He came to public. It cannot go beyond 940 rupees. And that he said it is an optimistic thing. His pessimistic was somewhere around 400 rupees per share. People who bought it at 3,000 rupees, now the value is 400 rupees. And you can't do anything. Even if you go to market to sell it 400 rupees, nobody will buy it. Nobody will buy it. That is what is happening. People are ready to sell it at face value 10 rupees also. But still nobody is there to buy the shares. With data, you can destroy businesses. With data, you can build businesses. That is the power of data. Data builds businesses. Classic example, Airtel. Jio gave free, na? Everybody said Airtel will go out. But did Airtel go? Did Airtel reduce the price? No. I am a customer of Airtel since my mobile phone use. I didn't buy any Jio SIM or Jio card because people who are using Jio, they were saying half the time network is down or it is slow, call drops, everything is going down. But Airtel didn't reduce the price. They stood still. Now what is happening? They are back to business. Jio is going to problem. Jio is in losses now. So that is what happens. Airtel decided they looked at the data. We have very loyal customers. They looked at the customers. Loyalty is there. 10 years, 15 years customer will not move to Jio. And he also found that people in families, multiple connections are there. Sunil Mittal analyzed the customer thing. Then he said, these guys will not do. So I will not reduce the price. He didn't reduce the price. I didn't move to Jio. So that is what happens. When you look at the data in a right context, your business will survive. Vodafone panicked. Idea panicked. Idea panicked. Idea, you know, right? Aditya Vikram Birla, he panicked. Had he not reduced the prices and had he also said, you should have Idea by now. But Idea guys could not handle the pressure. They went down. They also reduced the price. They went. Vodafone took over that company. But Sunil Mittal openly said, my customers will not go. I have the data. And none of his loyal customers moved. Some of them might have bought additional card, but their core is always, and he is now, treat him now, you know, I have 5 connections, my mother, father, I have 2 connections and my data card, and my monthly bill is 2,000 rupees. He is also giving me incentive. I pay 2,000 rupees. My father, my mother, I have 2 SIM cards, 2 connections and 1 data card. Family pack. My monthly bill with GST is 2,400 rupees. Because I stayed loyal to the company. Earlier I was paying my mother 600 rupees, my father 1,000 rupees. I used to pay with data 3,000 rupees. Somewhere around 5,000 something was my billing. Now I am paying 2,400 rupees with unlimited data. So that is the advantage if you have data. So he got the right customer. He didn't panic. And he is offering me incentives right now to stay with me. So that is what you have to analyze. Good CEO looks at the data, understands the data and makes a decision. A bad CEO will look at the data, don't understand anything, he will make a wrong decision. That is the problem with data. You have to understand it in right way. Simple hypothesis test, a lot of people misinterpret. So you have to be very careful in hypothesis test. You have to make a right decision, right choice, then you will have it. So we'll continue in the next session where we'll go with Excel-based calculation of ANOVA. And then one more test is there, chi-square test. That also we will discuss. And then paid sample test is also there. We will discuss them. So these are the common tests we use in business. These are the common tests we use in business. There are many other tests. Only those relevant tests which we use for business discuss in the